This video is on types of bonds. A bond is a mutual electrical attraction between the nuclei and valence electrons of different atoms that binds the atoms together. So nuclei, remember the nucleus is going to be positive and your electrons are negative. So there's that attraction there. So another way to say this is that it's a force that holds groups of two or more atoms together and makes them function as a unit. So bond energy then is the energy required to break a chemical bond. And so you have to put energy in to form a bond, and then energy is released when it's broken. So there are two main types of bonds that you need to know about. So first is a covalent bond. This is a sharing of electrons between two atoms. It's usually between two nonmetals, and it can be polar or nonpolar. So we're going to get into the polar nonpolar piece more in a little bit. So this would be, though, a bond like between, for example, if I had a chlorine with its 7 valence electrons, and we've drawn these Lewis structures, and it bonded with another chlorine, and I'll do this one in blue, like this, and this right in here in the middle here, this is the bond. These are the shared electrons. All right. An ionic bond then is chemical bonding that results from the electrical attraction between cations and anions. So we're talking about positive ions and negative ions. And there's an electrical attraction because we have a positive and a negative charge. So these are formed when an atom that loses electrons relatively easily, that would be a cation or a metal, react with an atom that has a high affinity for electrons. So that would be an anion or a nonmetal. So this cation or this metal, this comes from when the metals have low ionization energy. They will lose electrons. So I'm going to write low ionization energy, which means they lose, right, electrons easily. And when they lose electrons, they become more positive. So that's where the cation piece comes in. Anions or nonmetals, these are atoms that have a high affinity for an electron. So these have high electron affinity. So then when you add an electron, so they gain electrons to become negative. You're getting negative particles, so you become a negative ion. That's the anion piece. All right, so this relates also back to electronegativity from our last unit. So remember, electronegativity is the tendency to attract shared electrons. So this relates mostly to covalent bonds. So the higher the electronegativity, the more the electrons are attracted to that atom. So nonmetals will have a higher attraction than metals. So now in covalent bonds, use how both of these say covalent. They can either be polar or nonpolar. All right, so this is a really important concept in chemistry. So nonpolar means that the electrons in the bond are shared equally. And I'm going to put in parentheses, or almost equally. So to determine this, you look up a chart of electronegativity. And you'll see that there's one in your book on page 161. And can you look up the actual values of electronegativity for each element, and you just subtract them. So you could do like an absolute value, or you could always do like the biggest minus the smallest. If when you subtract, the difference is either 0 or as big as 0.3, that's going to be nonpolar, meaning the difference between them is equal or really close to equal. So they're sharing equally. So the electrons are perfectly spaced between those two elements. So like chlorine, for example, if you had chlorine and chlorine, right, it'd be the same thing. So a number minus itself, oops, hold on, come back here. Oh, let's actually just do this again. So if you have a number minus itself, you know you get the same thing, or you get 0, okay? So these electrons right here are equally spaced in the middle, okay? So this chlorine has the same amount of attraction as this chlorine. So they're not being pulled, like nobody's winning this tug of war. All right, so a polar covalent bond is when we have unequal sharing. So electrons, in the bond are shared unequally. So when you do the same thing and you subtract those electronegativities that you would look up, and the difference when you subtract them is between 0.3 and 1.7, that's when we have a polar covalent bond. So this would be something like chlorine with fluorine, and chlorine is 3.0 and fluorine is 4.0, and they both have 7 valence electrons. So as they each donate 1, those electrons are being pulled more towards fluorine because it's more electronegative. It has more of an attraction. So they're not shared equally. They're shared, but just fluorine is winning that tug of war. So you've got a little graphic here that shows you, like nonpolar covalent is when you're 0.3 or lower. Polar covalent is between 0.3 and 1.7. So they're more different. You got one that's winning a lot more. One is way more electronegative. And then ionic is anything above 1.7. So this is not equal sharing at all. This is not, or unequal sharing. This is not sharing at all. So this means for ionic that the more electronegative atom takes electrons from the less, electronegative atom. And what this will be is you will have the nonmetal takes electrons from the metal, right? So the nonmetal has higher electronegativity, higher electron affinity. So when you have something like, let's say you have NABr, you have sodium, and you have bromine. Bromine has 7, sodium has 1. What happens is sodium loses its electron to bromine. Bromine basically takes it away, which means bromine has a negative charge. Sodium has a positive charge. And when you have things that are positive and negative, they are attracted to each other. All right, so if you subtract their electronegativities, this is anything above 1.7 and up. All right, so I just wrote a couple examples, but let's do a couple more. So let's say we had, let's say we had like Cl and Br, for example. So I'd look up in this chart their electronegativities. So you'd be given that on any test if you were expected to use it. So chlorine is a 3.0 and bromine is a 2.8. So you take 3.0 minus 2.8 and you get 0.2. So 0.2 would be right in this range right here. So this would be what we call nonpolar covalent. All right, if I look at something like sodium and chlorine, sodium is 0.9, chlorine is 3.0. So if I do 3.0 minus 0.9, I get 2.1, which would be right up here somewhere. So this would be ionic, which makes sense because I have a metal in my chlorine or my sodium and a non-metal in my chlorine. All right, So those are bonds, ionic, covalent, and then within covalent, they can be defined as polar and nonpolar.